that the relation R in the set of real numbers are defined as R equal to AB, such that R is less than equal to B square is neither reflexive nor symmetric nor transitive. So let us check one by one. First, to check reflexive, I say that the given set, a given relation is not reflexive. R is not related to itself. Every element is not related to itself. Let's take an example. I mean, for some it may be, but it is not for all the examples. All real values. Let's choose A equal to half a real number. Then what about half less than equal to half square? What is half square? Half square is 1 by 4. So do you find half is less than or equal to 1 by 4? No. So half is not equal to or less than equal to 1 by 4. So conclude that the given relation is not reflexive. These are very tricky kind of questions. Then number 2, to check whether the relation is symmetric or not, let A is related to B. That means A is less than equal to B square. Let me take an example that 2 is related to 7. So 2 is less than equal to 7 square, fine. 2 is less than equal to 49. But what about 7 less than equal to 2 square? What is 2 square? 4. So 7 is not equal to or not less than equal to 2 square. So we can say 2 is related to 7, but 7 is not related to 2. Or in general, A related to B, A is related to B does not imply B is related to A, or we can conclude that the given relation R is not symmetric. And now to check transitive, it is also not transitive. Let me illustrate with the help of an example. A is related to B and B is related to C. For example, I choose 2A equal to 2, B equal to -3 and C equal to 1. Now see, 2 is less than equal to -3 square. Why? Because 2 is less than, how much is -3 square? 9. So 2 is less than equal to -3 whole square, right? And -3 is less than equal to 1 square, that is clearly -3 is less than 1. Now let us see, let us check that whether 2 is less than equal to A, 2 related to -3, -3 related to 1, that is there. But let us check whether 2 is related to 1, 2 less than equal to 1 square, or 2 is less than equal to 1, this is false. This is not true. So we can conclude that the given relation is not transitive, because whatever property we are checking, we have not to check that it is true for certain numbers, but it is supposed to be true if it is true for every, or if we could prove it false even for any three numbers, then it is not true. Okay, it is like this. Now next sum is, check whether the following relation defined on the set 1, 2, 3, 4, 5, 6, relation is AB such that B equal to A plus 1 is reflexive, symmetric or transitive. Now first of all I say it is not reflexive. Very clearly, if I choose any number A, then obviously A is not equal to A plus 1. A is not equal to A plus 1. For example, say 2 is not equal to 2 plus 1. How can 2 be equal to 3? So you can say A is not related to A, for A lies in the given set R, set of real numbers, not R, but let me call this 1, 2, 3, 4, 5, 6. This is set A. So A does not belong to, for all A belong to A. So we can say that the given relation is not reflexive. And now second, to check symmetric. It is also not symmetric. We'll see that it is not symmetric. If A is related to B, that means A equal to B plus 1. Or in other words, B equal to, B equal to A plus 1. Sorry, make a correction. If A is related to B, that means B equal to A plus 1. Or from here it implies that A equal to B minus 1. But for B to be related to A should be equal to B plus 1. So which is not true, which is not equal. We may take an example also. Suppose 1 is related, say 2 is related to 3, then 3 equal to 2 plus 1. Okay, now let us check whether 3 is related to 2 or not. Then 2 is not equal to 3 plus 1. So if A is related to B, then B is not related to A. So R is not symmetric. Now next, to check whether it is transitive or not, it is also not transitive. That very easily we can see. If A is related to B, that means B equal to A plus 1. And if B is related to C, that means C equal to B plus 1. And now replacing the value of B here, you get C equal to A plus 1 plus 1. So that way C equal to A plus 1, A plus 2, C equal to A plus 2. But for relation it should have been A plus 1. So we can say A is not related to C, and hence R is not transitive. So in the present sum, it is neither reflexive nor symmetric. Now the next sum is, given is a set of real numbers. The set is given to be set of real numbers. Set of real numbers. And the relation is defined as AB such that A is less than or equal to B. We have to prove that R is reflexive and transitive. R is reflexive and transitive but not symmetric. Let's see first of all reflexive. If I take any real number A, obviously A is less than or equal to A means at least A equal to A. So we can conclude that A is related to A, or the given relation R is reflexive. Now number 2, to check symmetric. If A is related to B, that means A is less than or equal to B. But that does not imply that B is less than or equal to A. For example, if 1 is less than or equal to 3, 1 is related to 3 means 1 is less than or equal to 3. But what about, is 3 less than or equal to 1? No, neither 3 less nor equal. So 3 is not related to 1. So this implies B is not related to A, and hence the given relation R is not symmetric. And now finally let's check transitive. So given relation is transitive as A related to B implies A is less than or equal to B, and B related to C implies B is less than or equal to C. And by simple property of inequality, A less than or equal to B and B less than or equal to C, then A has to be less than or equal to C, which confirms that A is related to C, or the given relation R is transitive. And hence the given relation is reflexive and transitive but not symmetric.